Well, hi, welcome to my shop here on July 5th. Today's a rainy day, so I'm in my shop. And what am I going to do? I'm going to change these capacitors here, these brown capacitors. That's what I'm up to today. Good. I'm going to get busy and do it. Oh, I've been working along here pretty quick. Without the camera running, I can work a lot faster, no doubt about it. So I've done all of these capacitors over here, and I think I've done one here, and what's left now is this big one. So I think I have quite a few lower voltage replacements of this size, but I don't have a 600 volt 0.33 microfarad capacitor. I can make it up with paralleling capacitors if I have to. The rating on here is 250 volts DC, 100 volts AC. My other capacitors are rated at 100 volts. I don't think it's AC or DC. So what would that be? I don't know. Would it be 100 volts AC? So I wanted to find out where this is in the circuit and see what it's doing. I noticed these wires are connected, at least the green one here is connected right to one of the terminals of this capacitor. Green wire goes down here and eventually reaches a terminal and a lighter wire which goes into the back of this control where these buttons are. So I think this is the heart of the automatic frequency disabling when you squeeze that tuning control and you push those white buttons. So that's where this is in the circuit. Somewhere related to that. I also see the other side is connected to, I can see it quite clearly, a 3 megohm resistor. There are not going to be many 3 megohm resistors in the radio, so that should allow us to identify this guy pretty good. Now we're going to take a look at the schematic here, and I've already hunted it down. It wasn't too tough. Okay, so this is where I believe it is. So if we follow one leg back, if we follow this wire, okay, it's the top wire here. Top wire. Here it comes down. This way it's 120 K resistor, and this other way, look at that, 3 megohms. So, you know, can't be many 0.33 capacitors, can't be many 3 megohm resistors, and this is physically in the right spot. Now what is it doing? So I have this interesting arrangement here of two identical resistors. We have a diode in here. So what exactly this is doing, I don't know. Is this how the, I don't know. Something to do with automatic frequency control, perhaps? What kind of voltage would be here? Well, you can't have too much across this diode. You can have a fair bit in reverse, but not forward. So we know this wire heads off to that gigantic resistor. Where's this going? Capacitor to ground. Some kind of variable control here. It looks like a one-time adjustment, like an alignment type adjustment, I'm guessing. W20. And this is not a front panel thing, I don't think. The switch here, 37. I wonder if 37 is the little white buttons on the tuning control. Switch 37. 37? 57? 37? Is there anything written about that? I don't remember seeing anything about S1, S6, that looks like 56. So this is S7, not 57, S7. S7, where am I going to find a note on S7? Let me just shrink this a little bit here. S7. Balancing control. Oh, this is what you plug in the wall. 50K potential plug in the wall. Plug in the back of the radio to affect remotely the balance. S7. I don't see a thing here. S7. They don't mention it. Ooh, what's that? Well, no S7 showing up here yeah. Take one last look. Where did you hide the diagram showing S7? What it actually is? We don't know. S7. There's no note around it to say what it is. Okay, well that'll remain a mystery for now, but I'm going to guess that this is actually the switch on the tuning control. Okay, so let's look at this. Now, still trying to figure out what is the voltage across this capacitor. Could turn the set on and measure it. That might be where I end up. Turn the set on and measure it. It's time to test it, test out all those capacitors anyway. Now this could vary a lot depending upon, you know, FM, AM, whatnot. I could take a false reading here pretty easily. Is there any hint? This is coming down in here. Well, that's unusual. This is the detector, FM detector. Putting back a little bit of DC back that way. My impression is there's almost no voltage across this. Well, let's go back the other way and just check that 3 meg resistor. Coming down here. It's coming down here. Oh, it's heading for the power supply. Right onto the power supply. So we got 228 volts coming up this wire. Coming up this way. 3 meg ohm resistor. You would think the voltage on the other side would be quite low, but it depends on the kind of current that's being drawn through here. Measurement. I'm going to have to measure it to find out. Okay, that's what we'll do. And at the same time, we'll test the radio and make sure it's working. That's not a bad idea. Okay, just leave it upside down. To hook up the speakers. Cats went outside today in the rain. They're outside for about 5 or 10 minutes and they come back in all depressed. Yeah, no fun today. But maybe it'll be better later today. Okay, so we have the 2 connected. And that's about all we need. Check. Yeah, take that clip lead out of there, Jim. Oh, whoa. Found a couple of near shorts in here with bare wires just passing, you know, less than a millimeter from another terminal, which I bent away. Okay, I think we're ready. Okay, so volume down. Volume is down. Power cord needs to be plugged in. I'm not expecting anything dramatic here. I expect the radio to work pretty much the same way it did after changing those capacitors. I had to test those capacitors. Hey, why don't we do that? Let's do that. Let's test those capacitors before I turn this on. Sounds like a fun thing to do. Here they all are. 0.01 capacitor. Some of them have this black seal on the end, others don't. What's that all about? Okay, here we go. 50 volts on the eye. Just a second. Make it easier to see. About the same, doesn't it? It's amazing how the camera can see the same and no matter what level the light's at. So watching the eye, I'll just report. Pop right open. Pop right open. It's popping open too fast. 350. It's popping open too fast. Oh, my lead is broken. What have I got? Okay. Yeah, popping open too fast, alright. Something quick I can do. Something quick I can do. I do something quick here. Quick. Let's do this. Fix that lead later. Okay, same deal. 50 volts. Watch the eye. That's more like it. I don't know if you can see what it's doing. Okay, it's not opening on 150, it's just opening a little bit. So that actually comes out a little bad. Now there's another black, a couple of black sealed ones. Let's do all those. The seal on this one just shattered as I was working on it. It's very kind of a fragile material. Here we go. 50 volts. Not all the way. Not opening at all. Not at all. So, hey, good to get rid of these. In the end, I was pretty sure I was going to get there anyway, but okay, here's another black-ended capacitor. 50. Opening about a third of the way on 150. So these should open completely. There, let's do this bigger one now because it also has the black tar. Maybe that was an employee suggestion at the capacitor factory. Make these better, Bob, if we put black tar on the end. At least people will think they're better. Here we go. Takes longer to charge. So it's just open maybe 15%. Okay, so not a waste of time changing these. Now what about these ones? Without the black seal. I would guess these are worse. There we go. Right open, 150. Open all the way. 250 having a little bit of a struggle. Another one with no black seal. What they're trying to seal is the very end of this. This is basically a rolled up paper, and they want to seal the very end. And the paper is exposed, and the edges of the foil are there, and the lead is coming out. It's a tricky area. Right open at 50. Not open at all. So they're varying. They vary. Now I wonder if that's because of the kind of service they had in the radio, although I'd be suspicious it's the temperature. That some of these are positioned close to a tube or in some place where they get hotter from adjacent components. And that's what degrades them. Right open. What about 10% if you're lucky? So these all tested a little worse than the other capacitors that I've done. Makes me feel a little better. Makes me say, hey big guy, you gotta go. But first we're going to test this now. back up a little bit. Put on my safety goggles. I'm only kidding. Okay, is everything safe? Everything looks good. Volume already checked down. Here we go. Watch those lights. Nothing. How come? Because I don't have any of these buttons depressed. Okay, let's depress. That's the AM button. Try again. Whoosh. Okay, I'm looking in this area for any smoke, which I do not expect. Yeah, when I work with the camera off, I'm able to concentrate a lot better. I go a lot faster, and I think I'm less prone to making errors. Maybe I spoke too soon. Okay, let me turn up the volume. That's a pretty familiar sound on the AM band. Tune it. And the radio works. Good. I'm going to read the voltage there now. Okay, I'm going to have to put the put it on full voltage. Just turn it down a little bit. Maybe I can push that button on the FM tuning and see what happens. So we don't have it on FM right now. We're on the 600 volt scale. 9 volts. Okay, let's put this on FM. I think, which way is that? I think this is FM here. It's FM. Same voltage. Now I gotta do something a little tricky here. I'm gonna try to push those switches while I'm making a voltage reading. Nothing. 8 volts. Is there any other circumstances here? Phono, in the phono mode? Could possibly. Just can't imagine something would happen now. 9 big volts. Put a low voltage capacitor there, 330 nanofarad capacitor, and we're done. Great. Okay, I've got my 330 nanofarad capacitor here. I just want to check it because I have a hard time with that color coding. And there it is, 324.5 nanofarads. Good. That's going to do it. This is a 100 volt capacitor. I'm going to cut this guy out and we're going to give him a test. So let me continue what I was doing. Not that it's terribly necessary here, but when I'm changing capacitors, I clip onto the lead terminal, or where the leads are going. Then I cut away the capacitor, and then if a cat comes and demands attention, when I come back I'll know where I was because of the clip lead. This is saying something about the remaining large capacitors that are up on top. There's a number of them still up there, up on top of the receiver. Okay. Oh yeah, I need the clip lead I just used. Oops. Give me another clip lead. Give me a good clip lead here. Okay, just checking my clip lead, make sure it's good. And it's not. Okay, we'll try another clip lead. Check this one. It's a winner. Okay, here we go. I think bigger means it's more leaky, or do you think it means it's going to last longer because it's so big? Black seals, they look beautiful. This capacitor, I mean, they don't look any better than this. Vintage capacitors like that. And here we go. Give it lots of time to charge up. Okay, it's about 25% open, 30, 40%, close to 50% open. But this is 50 volts. It should come open completely. For goodness grief, at 150 volts, it's just never going to open. So comparatively, this is a leaky capacitor. I think maybe the truth is the larger the capacitor, the more surface inside it, the more there is to leak. And what goes on in there? So they try to make these out of purified materials that don't have any ions in them. Paper is often used inside these. The paper has to be cleaned fantastically to wash out any of the ions. You can't bleach the paper either. If you bleach it, then it's full of bleach ions. Is that such a thing? Bleach ions? So you clean it as much as you can. Now over its life, as a little bit of moisture penetrates it, because there is a vapor, there's a moisture penetration rate through everything except metal. The moisture goes in, and then those few remaining ions are able to move around, I guess. I'm not exactly sure what the chemistry is on it, but it's all about moisture going in and activating poisons that are already in here. Okay, that's good. Well, I'm going to put in that other capacitor. We'll give it another test. We'll see what happens here. Maybe I'll flip it over and we'll test that FM tuning thing if I can. The AFC switch. Okay, time for a functional test. We'll start with the AM. Both speakers going. It's a station right there. Maybe not. French station at 860. Now I know when this was out in my garage it was receiving lots of AM stations, so it really is a detriment to be in my shop if you're a radio. Maybe for more reasons than I'm willing to admit. Now, FM. I've got a jury-rigged FM dipole antenna. It's just two wires in my shop. You can see the yellow one right here. This is showing let's take a look. See if the eye is doing the thing.
She was closest to.
Button.
And of course, actions have made.
Okay. Tuning.
I feel now to have outlived most people your age.
Letting go. Same problem.
Very, very lonesome. You know, friends,
Tuning without AFC.
Really, they're all gone.
No, it's doing the same
And
thing.
I can't get them back, so it's not easy, no.
We're listening to 91.5,
family,
and it's located at
it's
90.5.
it's okay. Well, I'm just
Squeeze this. Where'd it go?
Well, genetic
There it is.
possession and healthy living can stave off
It's at
age-related
91.
diseases. Staving off loneliness can be more of a challenge. But Ellen has found a way to beat that. Before the pandemic, she'd sit in the lobby of her condo building and
What's
knit
going on
winter
with this
hats
now?
and scarves.
So this is operating. There's a voltage setting on it.
Pass through the lobby and ask what she
Shouldn't be there. This should be popping open bigger, I would think.
Hit music.
You can see it working now. You can hear the AFC. Oh my. Mr. Bieber grew up not far from here. You know what? I don't think Mr. Bieber can sing on key. So it's quite clear that his voice is always being, what's that word? Where you process it to get it onto the note properly. I can't remember the term for it. But if you listen to his voice, it's always
is a blueprint for
way to go. I mean, maybe I could sing like that. Just run my voice through a computer, and I'll sound like Mr. Bieber. Mr. Bieber. Just working our way up the band here. Not pushing the AFC.
Each day, Dr. David Jen Turning Point worked to make a global impact for the kingdom of God. But we can't do it alone.
It's a very strong religious FM station right near here. Okay, now we should get some Toronto stations. There's one. AFC. Same thing happening with the AFC. Not bad at all. Okay. We're in very good shape here. What's left is some big capacitors involved in the tone side of things over here near the output transformer. 4 big ones, 5 big ones I think. I did one big one underneath, and the suggestion after testing that is, yeah, you know what, they all need to go. I haven't done any testing here of capacitors that makes me think, yeah, these guys are pretty good. I had a radio like that just a while ago, and I left them in because the few I took out tested really, really good. But not the case with these. Okay, I think that's it for today because I have to go to the grocery store now and live my life. Live my other life, and that's the story. So thanks a lot for watching, and tomorrow I will try to get rid of the rest of those capacitors, and then we'll have to pay some attention to this FM situation and make a decision around alignment. The issue being that the alignment adjustments are all waxed, so they're fixed in place. Honestly, I've never worked my way through a waxed radio. Okay, see you later. Thanks a lot for watching. Bye bye.